graph the first 6 terms of a sequence where A1 is 8 and B is -2. Well, if we're going to graph this sequence, we're going to need to create a table of values. So instead of x and y, which is really what they relate to on the graph, this is x and this is my y, I'm going to put n and an, because n is the number of the term, like the first one or the second one or the third one, and so on. And an is what I get when I plug that given n in. Now normally, well, they give us the first term, right? So the first term is 8. Now normally, to find the second term, I would take 2 and I would plug it into some expression that they give me. But they didn't give me an expression here. So I don't have anywhere to take this 2 and like plug it into to figure out what goes here. What they did give me though is a common difference. So the common difference that they gave me is -2, which means to get from any a sub n term to the next one, I have to subtract 2. Or you could think of it as adding -2. Same thing. So if I add -2, I get 6. And now that common difference remains consistent all the way through. So I do it again. 6 minus 2, 4. 4 minus 2, 2. 2 minus 2, 0. 0 minus 2, -2. And these are the ordered pairs that I'm going to graph. Always check your axis first. And when I look at my axes, my y-axis is counting by 1, and my x-axis is counting by 1. So nothing to account for there. So I'm just going to plot the points. So the first point is 1, 8. So that means from the origin, I'm going to go 1 right and 8 up. And then 2, 6. So I'm going to go 2 right and 6 up. And then 3 right and 4 up. 4 right and 2 up. And you probably see a pattern developing in the points where you might not even need to look at the chart for the last few. So what I noticed as I was graphing is that, actually I noticed it after the first 3, that to get to my next point, right, I would just go down 2 and over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And that makes sense because each time I increase my n by 1, I'm decreasing my an by 2. It also correlates to the slope of these points. If I were to connect them and find the slope of this line, which I'm not going to connect them because there are no values in our sequence that fall in between these 2 points, right? And there's no values in between 2 and 3. And there's no values in between 3 and 4. Like I don't have a 3.5 term, right? I have a 3rd term and a 4th term. So that's why it's not a good idea, or why it's not even correct to connect these. So don't connect them. But if I were to find the slope between any 2 points here in the sequence, I would get -2. Graph the first 6 terms of a finite sequence, meaning it has an end, where the first term is 2 and the ratio, the common ratio, is 1.5. All right, so now we've got some decimals in the mix, but we're going to do it the same way. So again, the first 6 terms. And then I'm plugging in, well, I'm not plugging in. Normally, I would take this number and I would plug it into the expression, but they don't give me one. What they do give me is the first term and the common ratio. So my first term is 2. And then my common ratio is 1.5, which means I'm going to multiply that by 1.5. And I'm going to do that all the way down the chart or the table. So 2 times 1.5 is 3. 3 times 1.5 is 4.5. 4.5 times 1.5 is 6.75. Multiply this by 1.5 and you get, I think it's 10.125, but let me just check to be sure. Yep, 10.125. Multiply this by 1.5, and you get 15.1875. And now we plot those points. So look to see how your axes are numbered. My y-axis is counting by 2's. My x-axis is counting by 1. So keep that in mind as you're plotting. So I've got 1, 2. Let me switch colors. So 1, 2, and then 2, 3. Then 3, 4.5. Then 4, almost 7, 6 3/4. So almost to 7. And then 5, and I'm going up to a little over 10. And then 6, and I'm going up to just a little over 15. So look, just like we saw in the last one, because it's a geometric sequence, smaller jumps at first, and then the jumps get bigger and bigger and bigger. Right? So that would be the graph of the first 6 terms of this finite sequence. All right, one more. Graph the first 6 terms of a finite series, where A is A1 is 2 and R is 1.5. So these are the same ones that we just looked at. Our first value is 2, and our common ratio is 1.5. The difference here is we're graphing the first 6 terms of the series, which means not only do we have to find the terms in the sequence, but then we have to add them up to get the terms of the series. Okay, so let's do it. We're going to start off the same way we did on the last one. Actually, let's see if we can go back and just pull all of this over. Maybe not. Oh, there we go. All right, so this is what we did on the previous page, right? We plugged it in, we found all of that. I'm going to get rid of this. And we're going to add to this table because we weren't asked to find the sequence here. We were asked to find the series. So we need another column. And this column is going to be our sum column. So I'm going to call it S sub n. And our sum column is going to be what we get for a sum as we go, kind of like a running total. So at this point in this first, if all I have is the first term, which is 2, my sum is going to be 2, because that's all I've got. I've just got that one number. When I list the first and second terms of my sequence, and I add those together, 2 plus 3 is going to give me 5. And that's the sum up to this point, right? So now what if I want the sum up to this point? Well, 2 plus 3 is 5, and then I'm going to add on to that 4.5, so I get 9.5. See, so I'm adding all 3 of these to get this sum. So now I want the sum up to here, which means I'm adding all 4 of these to get this sum. Right, so let's add it up. We know that 2 plus 3 plus 4.5 is 9.5. And then, so up to this point it's 9.5. Then we have to add this number on. So 9.5 plus 6.75 is 16.25. And now I keep going. Now I add this number on. I add on 10.125, and I get 26.375. And then the last one that they want me to add on is the 6th term. So I'm going to add 15.1875. And that gives me 41.5625. Now, I no longer need this column, because I wasn't asked to graph the sequence here. I was asked to graph the series. So this is what my points would look like if I'm graphing the series. Disregard that middle column. We don't need it anymore. So these are the points that I'm going to graph. So let's graph them. 1, 2, and notice the y-axis is counting by 5s. 2, 5, 3, 9.5, 4, 16.25, 5 and 26.375, and then 6 and 41.5625. And let me just add those numbers up again just to make sure. 9.5 plus 6.75 plus 10.125, yep, plus 15.1875. Yep, that's it. So we graphed all of the points in the series. Now remember, how do you know when you have to make this third column? It's only when you're asked to graph a series. So if you're asked to graph a sequence, then you just do it the same way we did all of the other ones. You have an n column and an a sub n column, and you graph those points. But if you're asked to graph a series, that means that you want the sum up to that point. So these 2 added together give me 5. These 3 added together give me 9.5. These 4 added together give me 16.25. Okay, so that's the difference.